Understanding waves for paddlers, an interesting subject. We'll cover wind waves and also boat wakes. One day the ocean could be nice and flat like it is in this picture. An hour later, wind chop can build up like this, or even like this. And the next day it can get even bigger. All of these are wind-generated waves. How wind waves are formed. All wind waves start out as small ripples on the surface. The higher the wind speed, the longer the time and the distance over which it can blow, the bigger the waves can get. The larger the wave, the faster it travels, and waves sort by size as they move out of a storm area. Over distance, waves become swell, which cross entire oceans without diminishing in power. Locally produced waves are called sea, and the organized waves that eventually form are called swell. I want to talk about the structure of waves and how the energy is moved through the waves. As the wind waves form, wind energy is transferred to the water. As the wave moves across the water, the molecules of water actually make a circular motion. The energy diminishes as you go deeper. And it disappears when the depth equals 1/2 the distance between wave crests. Waves from the same source traveling together are called wave trains. When catching waves in deep water, notice that the wave seems to disappear. You're on the wave and then it seems to die out. The next wave comes up behind you. But what's going on with the wave energy? Why does this happen? Why do the waves only last for a very short time? On the surface, the molecules travel fast, but halfway down, they travel at 1/2 the speed. And at the bottom of this energy, they barely move at all. So the group velocity of the wave train is 1/2 the speed of the surface waves. Essentially, the waves outrun the energy that really forms them. You can see this easily with boat wakes. If the waves didn't outrun the energy, they would spread out like these lines above in yellow. But the waves do outrun the energy, and you can see that they taper off quickly, and new waves form behind them from the energy that's beneath the waves. To stay on a boat wake, you need to travel the same direction and speed as the boat. You can see this wake vanish just a few meters in back of these people on the SUP. There is a tendency to catch the wake at 90 degrees to the face, but you will quickly outrun the energy of the wave train. Then you have to wait for the wake to catch up again. If you can run more in the boat's direction of travel, you can ride it for a lot longer. Wave interactions. Often waves come from more than one source, and when they cross paths, they interact. When a crest meets a crest, they add together, forming a larger wave. And when a crest meets a trough, they actually cancel each other out. Here are two waves doubling up, and you can see the size of this enormous wave. In the ocean, we often have more than one source of waves, and these combinations of waves can form together to create wave sets. On the ocean, there are usually many wave sources, and they're of different frequencies and different sizes and directions. To complicate things, waves can also reflect off steep shorelines, even steep beaches. Doesn't necessarily have to be a cliff like here in Santa Cruz. You can see these waves bouncing off this wall, and they can be felt pretty far out to sea. Also, when waves reach shallow water, they can be bent because they slow down in shallower water. To read the water, you need to be able to see all of the waves on the surface. Here, crests have not quite combined to make a really steep wave. You need to try to anticipate how they will affect your boat as you're going through them. Here you can see the waves are still not quite aligned, but watch the next wave and you'll see that the peaks coincide. When you're running downwind, remember that the wave in front of you will be replaced by one from behind you. So it's always the energy underneath creating the waves. Try to put your nose into the pit behind the wave in front of you. Even the smallest waves can push you along. This guy uses them really well. Use the small ones to help you get on the bigger ones. Be ready to turn a little left or a little right to get to the next pit. Try to connect the bumps. Running downwind in an OC6, waves from any angle can push the back end over first. Learn to anticipate this. You'll see Uncle Les poke on the right as a wave comes slightly from the left side. Shallow water waves. When waves reach shallow water, the energy beneath them drags on the bottom. It slows the wave down, and the energy forcing upward creates a peak. The wave no longer outruns the energy, so it doesn't fade away. Where the wave breaks is complicated. The bottom profile and steepness of the beach, and the size and speed of the wave, and the combination of waves all play a role. Heading out through surf zones can be dangerous. Take time to observe the set interval. Choose your moment, head straight into the waves, straight out, and paddle hard. Treat a large boat wake just the same as a large wave. In deep water, going out through a large steep swell, it's best to take an angle. It reduces the pounding and allows seat 1 to paddle more. Here I'm watching for low points on the crest to aim for, where the waves haven't quite peaked together. Even in small waves, returning to the beach can be hazardous. The stern can get pushed quickly to one side. You have to anticipate this. You can see this guy poking to the right now. It may be safer to slow the boat down and let the waves pass under the boat rather than actually catching them. Then you follow one of the waves into the beach. Allows you to have control. Remember that these waves have a lot of power. Always avoid letting your boat get between you and a wave. The wave can push it really hard, and there's no way you can stop even a small craft. Before you head out, you should know the weather forecast and the limitations of your crew and of your equipment. Always be ready to not go out. Just stay on the beach and be safe. Always put safety first.